Alright students, let's see if given an equation, how to determine if it is in direct variation or not. So, a direct variation can be written as an equation in the form y equals kx, where k represents the constant of variation. In other words, we can call this as slope. And students, make a note, the same equation can be written as y equals kx, y equals mx, or y equals ax. They all mean the same. They're all different forms of writing it, but they all represent the constant of variation, k, m, and a. It doesn't matter in which form it's been presented to you. So let's look at a here. It says y equals 6x. This is of the form y equals kx. And this is in direct variation because I do not have any number that's being added or subtracted to the x term. So yes, this is in direct variation, and the constant of variation here is going to be 6. Because 6 is the coefficient of x, right? Whatever is the coefficient of x, that's your constant of variation here. And let's look at b. Y equals 4x minus 1. If you compare this to the equation y equals kx, then you would see that I have a number that is being subtracted, which shouldn't be the case. So this is not an example of direct variation. Whenever you have a constant that is being added or subtracted, then that's not an example of direct variation. Let's look at C. Here it says y equals half times x. So again, this is of the form y equals kx. So yes, this is in direct variation, and k here is equal to half. Please make a note for yourself. K, or the constant of variation, right? It can be whole number, fraction, positive, or negative. Just like our slope, it can be any or a combination of these four. So once you made a note of that, now I'm going to erase this because I don't have space to show you how to work on number D, or letter D. Okay, it's 3y equals 6x. Now here, this is not in the form y equals kx because I have a coefficient or a number that is being multiplied to y, right? Which is 3 here. I don't want the 3 over there. So do the inverse operation because it's 3 times y. Now you have to divide 3 on both sides so that you have just y on the left side of the equation. So when you simplify this, it's going to be 2x, or 2 times x. So in other words here, k, or the constant of variation, is 2. This is in direct variation, students, because I do not have any number over here that is being either added, subtracted to the x term. So this is an example of direct variation. Now at this point, students, you can pause the video and work on letter E, F, and G, and then play it to check your answers. So moving on to letter E, the same concept, students. I don't have y all by itself. I have a number or a constant that is being multiplied to y. So to get rid of the number, divide on both sides by 5. So you have y is equal to x divided by 5. The same thing, students, We can write this as y is equal to 1 over 5 times x. Do you see that? The constant of variation now is a fraction, which is 1 over 5. And this is a perfect example of direct variation. Let's look at the next problem here. 5y minus 15x equals 0. So I need y and the x term on either side of the equation. I don't want them both on the same side of the equation. So in order to bring it to the direct variation form, I'm going to move the x term to the other side of the equation by doing the inverse operation, right? I'm going to add 15x on both sides of the equation so that I'm left now with 5y is equal to 15x. Again, I'm not done here because I have 5 times y, which is not what is needed, right? So divide on both sides of the equation by 5 because 5 is the number that is being multiplied to y. So to get rid of that, we did that, and you're left with y equals 3x, which is again a perfect example of direct variation with a constant of variation is equal to 3. That's your answer for letter F. Alright, so now I'm going to work on letter G, but I'm going to do the work right here. I'm going to write it as 3y plus 6 is equal to 9x. Alright, so again, I have to do the adding or subtracting. Like I have to do the opposite operation and move the constant, that is 6, to the other side of the equation. So since 6 is positive, I'm going to subtract 6 on both sides of the equation there, and left with 3y is equal to 9x minus 6. Now again, this is not the final answer. I have to divide by 3 for each of these terms because I want y all by itself, and whenever you do any operation you have to do it for all the terms in your equation. So now this is my final answer, but look, I have a number here that is being subtracted from the x term, which is minus 2. So this is not an example of direct variation. Alright, so let's move on to the next one, which is your graph. If given a graph, how do you know if it is in direct variation or not? Alright, so here the notes for the graph of a direct variation is always a straight line. It cannot be a curve or a parabola or a hyperbola. It has to be a straight line that goes through the origin. It always goes through the origin, which is nothing but 0, 0. So let's look at this first question here. Graph each direct variation below. Okay, how to graph it? Let's see, y equals 3x. This is of your slope-intercept form, students, except that here my b will always be 0. So if my b or the y-intercept is 0, that's your first point here. Begin with your origin, right? Make your first point there, and then look at the slope. The slope here is 3. If it is 3, make it as a fraction. And then use those numbers to plot your points. Since it is 3 over 1, go up 3, write 1. Do the same thing. But to do the same thing, I don't have any more space to go up. So I'm going to go down 3 and then go to the left. And then draw your line. This is the way to graph a direct variation. Okay, there I have letter B. Moving on to the next one, same thing here. Y-intercept is 0. So begin with your 0 right there and look at your slope. It's a negative slope. It is negative 1 over 2. So I have to go down 1 and write 2. That's my second point. And I don't have any more space to go to the right. So do the opposite. Go up 1 and left 2. There's my 3 points, and draw your line. Students, you can pause the video right now and work on C and D and then come back and check your work. Play the video and then check. So, for letter C, it is not of the form y equals kx. So I have to divide on both sides of the equation by 3. So there, now I'm left with y equals 2 over 3x. Again, notice there's no y-intercept. So it's the same as adding 0 to this, right? So there's my first point. On your origin, make a point right there. Use the slope, which is 2 over 3. This is my slope. Remember, the coefficient of x is your slope. So go up to right 3 and do the same thing. But I don't have any more space to go up, so do the opposite. Go down 2 and left 3. And there. Draw a line, or let me try to make that perfect straight line. Okay. There. So your line should pass through the origin. Let's look at the last one over here. I have to divide on both sides by -4, students, because I cannot have a coefficient for y other than 1, right? So now y is equal to -1 over 4 times x. The same concept. I can add a 0, but that's it. That's all I can do and not change the equation. So there's my origin. Make a point there and use the slope. So for the slope, I have to go down 1, right 4. And do the opposite, as I don't have any more coordinate plane to plot the point. To do the opposite, go up 1 and left 4. There's my straight line. Alright? Now for the last one. Write an equation for the direct variation graphed below. Alright, students, remember from the notes we had used before, or we wrote it before. The constant of variation, just to remind you, the constant of variation is equal to slope. And to write an equation, direct variation, students, you know that y is always equal to kx, right? And k is nothing but your slope. So let's calculate the slope here. There's my point, right? You have the 2 points. So let's figure out the slope here. Going up 1, 2, 3, 4, 5. So numerator is 5 divided by the run from here is 1, 2. So that's your answer. The final answer is y is equal to 5 over 2x. Alright, students. See you on Monday.